Welcome to week 4, our first lecture on neuromotor control and proprioception, functional and performance-specific development. So in this week's lecture series, we are looking at chapters 14 and chapters 15 in the rehabilitation of MSK injuries, our course textbooks. So we will get started with the concepts from chapter 14. So here is a reminder, here are the course readings. Here are the objectives. And we've spoke previously about afferent versus efferent receptors and how they play a role in the nervous system to send sensory information to the central nervous system for processing, after which your efferent receptors or your efferent neurons send information outward towards this skeletal muscle to produce a particular response. Now, the neuromuscular integration obviously is very important when considering control or execution of movement. And so in this particular chapter, we are first going to speak about the different elements of proprioception, and we'll start off there. So starting out with the various components of proprioception. So proprioception refers to the body's sense of position and postural adaptations. This is a component that is worked on, or the various elements of proprioception are worked on during a rehabilitation program. And specifically, proprioception is comprised of agility, balance, and coordination. It is obviously necessary for individuals to have flexibility, muscle endurance, and muscle strength as well. But proprioception is obviously central to being able to execute any skill that has or involves accuracy, precision, and consistency as well. So proprioception also is important in correcting performance, and agility, balance, and coordination come into play a very vital role in helping to execute those particular motor skills. To optimize proprioception in any activity, we must understand what proprioceptors are and how they affect both skill and the execution of a movement. So that is where we are going to start. So firstly, we are going to start off by defining some of the receptors that are involved. And those receptors include the exteroreceptors, which obviously play a role more in understanding the external environment, versus the interoreceptors that play a role in understanding the body's internal environment, and our proprioceptors particularly referring to that, once again, a body or a segment of one's body and how it is positioned in space. So if we focus in though on proprioception, it has been defined previously, and it is existent within this general category or categorization of these various somatic receptors. And these various receptors that I've just mentioned are considered to be sensory receptors. They all are able to provide afferent information to the central nervous system, as I've just described in the preceding slide. And although there are various ways to classify these receptors, what I have just described with your exteroreceptors, interoreceptors, and the proprioceptors, these collectively are able to once again relay that sensory information. Proprioception, if we define it in more depth, it is the body's ability to transmit position sense, interpret the information, and respond either consciously or subconsciously to stimulation through the appropriate execution of posture and movement. And as a result, we can think of proprioception as being responsible for the afferent stimulation that actively moves and positions one's limbs. Now we also have these mechanical receptors, the mechanical receptors that are specialized afferent nerve endings that can respond to mechanical stimulation, and this includes pressure, tension, and vibration. So you can see the various receptors, such as your Golgi tendon organs, which we speak about in this course. And you can see their location. So for example, your Golgi tendon organs are located within the junction between the muscles and the tendons, and they are able to detect muscle tension, and they respond to muscle stretch and contraction. So that is just one example, but once again, these are a series of specialized afferent nerve endings that respond to mechanical stimulation. Now, as we've already alluded to, these proprioceptors play a vital role when it comes to executing motor skills. And so they are particularly important when it comes to activities or tasks that involve dexterity, mastery, and proficiency. Proprioceptors, therefore, are important when it comes to performance, whether it be for performing your activities of daily living or your ADLs, work tasks, or more complex athletic endeavors. The better the proprioceptive system works, the better we will be able to execute or perform a given movement. And that takes us to our next slide. Once again, here you can see the neurophysiology involved with proprioception. You have a series of afferent receptors, okay, all located within these various tissues, so the skin, the joints, ligaments, muscles, and tendons, some of which we've already referenced. And once again, it is the afferent receptors located within those structures that are able to relay sensory information to the central nervous system as outlined in the diagram here. And you can understand how we have these various types of receptors that not only relay the information, but then once information has been processed within the central nervous system, then we can execute those particular movements and hopefully with a certain level of skill, dexterity, mastery, and proficiency. So I'm going to break this down a little bit further, but we have cutaneous receptors. Honestly, they do not play a major role in proprioception. They can provide some cues. So they're located, as I mentioned, cutaneous, so they're in the skin. So they provide cues about skin stretching or perhaps fingertip touching. You also have muscle and tendon receptors. And so there are several factors which will influence neuromuscular performance here. And one such example is the stretch shortening principle. And so it is based on our knowledge of the neuromuscular system and the mechanical components as well as the neurological components. In particular, we have both contractile and non-contractile elements that you should be aware of. Our contractile components include the myofibrils, which contain the sarcomeres, which, as you know, play a role in muscle contraction. And so muscle is the only structure in the body that actively shortens or lengthens to produce movement. The contractile elements of the muscular system also control the non-contractile elements. The non-contractile elements or components include the muscle's tendons and the connective tissue surrounding the muscle and its fibers. They are named according to their arrangement and include tendons, sarcolemma, as some examples. Okay, and now we'll move on and go a little bit deeper, looking at those neurological components. So the muscle spindles and the Golgi tendon organs, as I was speaking to earlier. So once again, the proprioceptors that play important roles in stretch and shortening muscle type activities are both the muscle spindles and the Golgi tendon organs. The muscle spindle is stimulated by sudden changes in a muscle's length. So for example, when we have concentric or eccentric type movement, that can produce a stretch or the change in the length of the muscle. And so you can have muscle shortening as an example. And the stretch reflex itself is a very basic sensory motor response. It goes directly from the afferent sensory nerve or the muscle spindle to the spinal cord, where it can make contact with the efferent motor neurons and produce a very rapid response by the muscle. In this case, where you have that very much of a direct connection to the central nervous system, and because no additional nerves are involved in that relay process, the stretch reflex tends to be a very fast, or one of the fastest reflexes in the body. Now, I should also mention the muscle spindles and the Golgi tendon organs are the primary afferent receptors of your muscles and tendons. Most afferent receptors of a joint lie within the connective tissue and the surrounding ligaments. As a result, their main purpose is to influence proprioception in end range type positions. And they are further classified or divided into different fiber type groupings. So you can see group 2, group 3, and group 4 highlighted in the table here. And they include both proprioceptor and also the receptors, the nociceptors that sense pain. Now, ligaments also contain receptors, and although receptors have been identified in different joints, so such as they've been identified in both the knee region and the shoulder region, the most commonly investigated ligament receptors are those in the ACL, or the anterior cruciate ligament. So these receptors are generally not active in the middle ranges of movement, but are stimulated when a ligament is stressed in its lengthened state. So they can produce an inhibitory response of the agonist muscles. You can also have a collaboration of the afferent receptors, such that the central nervous system is able to integrate and interpret any sort of sensory input to create movement and positional information as well. There is now evidence to demonstrate the neurosystem's complexity in response to facilitation. So once again, the central nervous system is instrumental in not only grouping, but also interpreting that sensory input to create movement, as well as facilitate input into the upper centers. And that is not from just individual afferent receptors, but from groups or populations of receptors. And so these are some of the sites within the central nervous system. We have the spinal cord, brainstem, and cerebral cortex. And so once the afferent nerve have sent their information, that sensory information, towards the central nervous system. Once again, the body's motor response is determined by the location within the central nervous system that interprets the stimuli, that sensory information, and initiates the efferent reaction. There are several areas within the central nervous system that can activate in response to a stimuli. And so although there are a number of areas within the brain that can be activated by a proprioceptive input, the three primary areas are listed here. So the spinal cord, brainstem, and cerebral cortex. In terms of the spinal cord, when an impulse goes from the dorsal root afferent nerve directly to an efferent nerve in the spinal cord, it can act quite immediately, and that is referred to as a spinal reflex. And so this is an efferent type response in a very simple form. If we're considering the brainstem, you can think of the brainstem as somewhat of a switchboard through which you have incoming and outgoing information that is continually being sent to and from the higher brain centers. You also have sensory pathways that can travel to the cerebral cortex, and this is the highest level of the brain and where we experience consciousness. So that is the center for voluntary movement, and it is here in the cerebral cortex that correct movement is learned and also consciously controlled and corrected before it becomes an automatic type response. So anytime, for example, during a rehab program, when you're learning a new movement, it will very much involve conscious input before you, so to speak, perfect that movement and it becomes automatic or subconscious.